Good morning. In our previous video, we have shown how to construct the Pert network. This is the chart given. Here the activities are shown. The preceding activities of these particular activities are given, and the optimistic time, the most likely time, the pessimistic time, the mean. What is the mean? The mean, that is the expected time duration for each activities. That is, for completion of A activity, the time is 3, and the standard and the variance sigma square is given. Now mu, the formula is mu is equal to TO plus TP plus 4TM divided by 6. You can easily verify this mu with the given data TO, TM and TP. So our first task is to construct the network from this given project. So A and B, these are the mother activities. So A and B. So A is the this activity and B is this activity. A and B, right? Now the completion for A is 3, that is mean. So 3. For B, this is 4. That is the weight of these activities. Next, C. C comes from the completion of both A and B. So, how to construct the C? This is our C. Okay? And C comes from completion of both A and B. So we can use a dummy activity and we can shift this B towards this point so that C comes after this completion of both A and B from this middle point. Now for C, the resource is the completion time is 5. So this is 5. Next, D comes from B. D comes from B. This is our D, and the time taken for D is 5. Okay. Next, E comes from D. E comes from D. E comes from D. This is our E. E comes from D. So this is 7. And F comes from C and E. So this is the completion time of C and D. So F comes from this point after the completion of C and E. And the resource is 7. The resource is 7. Okay. Next, G comes from D. G comes from D. This is G and the completion time is 8. So this is the project network that can be constructed from the given project. Here you can use another dummy activity to shift the end point of E towards this point, and we optimize this point, and C we join this C and E in a common point. Okay. Now from this network we have to find out the critical path. We have to find out the critical path of this network. What is the critical path? So we have to use the forward pass and backward pass. So forward pass, box A. So box A, always box A is 0. Next we have to find this box of this particular event or node. event and node are different with arc and activity. Next, box of this event. Box of this event is 4. Why 4? Because this one plus the duration, so this is 4. For this is 3. Okay? 3. No. Max of this path and this path. So this will be 4. I think this will be 4, so 4. Next, box of 5. Box of 5, this point. So 4, box of this is 4. 4 plus 5, that is 9. 9, and box of this one, so 4 plus 5 or 9 plus 7. So 9 max of this, so 9 plus 7 is the maximum. So the value is 16. Value is 16. 9 plus 7, 16. Next, box of this one. Box of this one means 16 plus 7 is maximum or 9 plus 8 is maximum. So we take the maximum value, that is 23. 23 is the maximum value. Next, we have to calculate the backward pass. So triangle of the last node is equals to the box of the last node. So 23. Next, this point. So 23 minus 8. So 23 minus 8. When we use the backward pass, so this will be your, so from this point we have two outgoing edges. So first calculate this point. So 16 minus 23 minus 7. 23 minus 7, that is 16. Now which one, to calculate this point, which one is minimum? 16 minus 7 or 23 minus 8? Obviously 16 minus 7, so 9 is this point. Next, calculate this one, 9 minus, from this point we have two outgoing edges, we have to take the minimum value. 4 minus 0 or 9 minus 5, both are same, so 4. Next, this is 16 and this is 5, so the value is 11, and the value is 11. Next, for this one we have two outgoing edges, whether 11 minus 3 is minimum or 4 minus 4 is minimum. 4 minus 4 is minimum, so 0. So at the first point, 0 forward pass, that is the latest occurrence of the first node, is equals to the earliest occurrence of the first node. So the computation is correct. So now we have to calculate the critical path. What is the conditions? First condition is the triangle J is equal to box J. Second condition is the triangle I is equal to box I. And third condition is that triangle J minus box I is the duration of the activity Dij. So these are the conditions. So using these three criteria, we can easily compute the critical path. So this one is the critical path. So this one is the critical path. Next, 4, 4, 9, 9 and 9 minus 4 is 5. So this one is another critical path. Next, 9 and 16. 9 and 16. So this one is the next critical path. And finally 16, 23. So this is another critical path. So the final critical path is your B, next D, B, D, next E, next F. So this is the critical path. Okay, and the cost is, what is the cost? So cost will be mu B plus mu d plus mu e plus mu f. So if we add, we get 23 units. So the project completion time, expected time TE or mu is 23 unit. Okay. Now, if you are asked by what time we are 95% sure of computing the project, we are 95% sure of computing the project by what time? We are 95% sure of completion of the project. So the formula is Z is equal to T minus TCP divided by sigma. So what is TCP? 23 units, the expected or your mean of the network beta distribution. And 95% is the probability. So 95% of the probability, for 95%, if P is 95%, then Z will be 1.65. Don't worry, this will be given. So Z at probability 95%. So 1.65 is equal to T minus 23. And what is sigma? What is sigma? Sigma is equal to sigma B plus sigma D plus sigma E plus sigma F. So the value is, sigma value, standard deviation value is 1.825. Okay. Now if we put the value of sigma, standard deviation of the entire project, 1.825, we can get the value of T. T is equal to, nearly is equal to 26 days. Okay. So by what time? So 26 days is your correct answer. Okay. So in our next video we will discuss another problem. Okay. Thank you.